All right, today we're diving deep into the world of modern crime fighting. We're going way beyond the usual stakeouts and informants to see how intelligence agencies are using data to literally unmask entire criminal empires. We're going to look at how they can map a hidden organization, pinpoint its leaders, and take it apart from the inside out, all just by analyzing who talks to who.
So, get this. It sounds like something straight out of a Hollywood spy movie, but I promise you, this actually happened. The FBI, working with the Australian Federal Police, secretly created their very own secure messaging app called AINM. And then, and this is the genius part, they used an informant to get these special, unhackable phones right into the hands of organized crime syndicates all over the world.
And for years, this app was the perfect Trojan horse. Every single message they sent, planning drug shipments, coordinating hits, laundering money, every last word was secretly being copied and sent directly to law enforcement. The operation was, a massive success. But it also created an equally massive problem. You've got millions of messages flooding in from over 12,000 devices. At that point, investigators weren't just looking for a needle in a haystack. They were literally drowning in a sea of digital chatter. So how do you possibly turn all that chaos into a clear picture of who's actually in charge? Well, the trap was set very patiently, over almost 3 years. The first devices got into the criminal underworld back in late 2018. It wasn't until mid-2021 that authorities felt they had enough intelligence to execute this huge, coordinated takedown across the entire globe. And the results were just incredible. In one single, coordinated sweep, over 800 arrests were made in 16 different countries. They seized tons of drugs, hundreds of firearms, and millions in cash. But the goal here wasn't just to make arrests. It was to understand and permanently break the very structure of these global organizations. To see that hidden structure, they needed a whole new kind of blueprint. And they found it in this really powerful method called social network analysis. It's a way of taking all that messy, chaotic communication data and turning it into a crystal-clear diagram of the entire criminal enterprise. At its core, social network analysis, or SNA, isn't really about what any one person is doing by themselves. No, it's all about mapping the relationships between them. Who's talking to whom? Who's working with whom? It basically lets you see the invisible web of connections that holds these entire groups together. Okay, so every one of these network maps is built from two really simple things: nodes and edges. Just think of nodes as the dots on the map. They can be people, companies, even bank accounts. The edges are the lines connecting those dots. They represent the relationships: a phone call, a money transfer, a meeting. You start mapping these out, and suddenly, a hidden structure begins to appear. So once you have the map, the next question is the big one. How do you find the kingpins? Because it's not always the person sending the most messages. SNA gives analysts specific mathematical tools to pinpoint who truly holds the power in the network. So, how do we even define important? Well, the simplest way is what's called degree centrality. You just count who has the most direct connections. But a much more powerful measure is eigencentrality. This concept argues that it's not just about how many people you know, it's about how important those people are. Think of it like Google's original PageRank algorithm, right? A link from a major news website is worth way more than 100 links from some random blogs. It's the exact same idea here. A connection to the boss is way more valuable than connections to 10 low-level guys. And this illustrates that idea perfectly. What you're looking at is a network map of the corrupt South African arms deal. The dots, or nodes, are people and corporations. Now, the size of each dot isn't based on how many connections it has, but on its influence, its eigencentrality. See how some nodes are huge, while others, even ones with a bunch of connections, are pretty tiny? Let's look at a really specific example here. The state-owned company Denel only had 5 direct connections, but look at the size of its node. It's just as big as the major contractor that had 20 connections. So why is that? It's because Denel's few connections were to other incredibly important central players. If you took Denel out of the picture, it would cause a massive disruption, and that's what reveals its hidden structural importance. But here's the critical challenge, and it's a big one. Social network analysis is only as good as the data you feed it, and in the secret world of criminal investigations, you almost never have the complete picture. There's always a ghost in the machine. So let me ask you this. What's more damaging to an investigation? Missing a whole bunch of phone calls, or failing to identify just one or two key suspects? The answer, well, it might actually surprise you.
Here's the crucial insight from the research. It turns out you can actually miss up to 10% of the interactions, the edges, the phone calls, and your overall map of the network stays pretty accurate. But if you fail to identify just 2% of the key people, the nodes, your whole analysis can become dangerously misleading. And why is that? Because you might end up targeting some middle manager thinking they're the kingpin, while the real boss stays invisible, completely free to just rebuild the network.
As the researchers who figured this out put it, missing even a tiny fraction of suspects can lead to a significant misinterpretation of the entire organization. This just shows the immense pressure on intelligence gathering. You have to identify all the key players, or your beautiful map could lead you in the completely wrong direction. Not only that, but the evidence it generates might not even be allowed in court. So, you see, S&A is this incredibly powerful method, but it is absolutely a double-edged sword. It needs sophisticated tools and, maybe even more importantly, highly skilled analysts who know how to use them right. To do this kind of complex work, analysts rely on a whole specialized digital toolkit. You've got commercial industry standards like Maltigo or Analysis Notebook, which are designed specifically to help investigators visually link different pieces of data. And then you have powerful open-source tools like Gephi for visualization, which are often paired with coding languages like Python to crunch the massive datasets that these investigations create. But you've got to remember, these are just tools. They don't just spit out answers on their own. The real magic happens in the hands of a skilled analyst who can see the patterns, understand the context, and transform that confusing tangle of lines and dots into clear, actionable intelligence that can actually take down a criminal network.
And this leaves us with one final and really important question. Operations like Trojan Shield show the incredible power of network analysis to keep us safe. But as more and more of our lives are captured as data points, how do we as a society strike the right balance between using this power for good and protecting our fundamental right to privacy?